Hello students, today we are going to see three-phase inverters with 120 and 180 mode. So that is again software based experiment, three-phase voltage source inverter using 120 and 180 degree mode. So what do you mean by 120 degree and 180 degree mode? So basically here, whatever transistors that we are considering, they will either conduct for 120 degree or 180 degree. So why we are using transistors over thyristors? Because thyristors need commutation circuit for, if we are talking about DC, that is forced commutation circuit. Okay, so we are using transistors. So it is very simple to make the circuit. So first we will go to switches. I will consider any transistor, MOSFET or IGBT. So let us take IGBT. So see, I will need 6 IGBTs for my circuit as it is a three-phase configuration. Plus you can see here the feedback diode. So what is the difference between feedback diode and freewheeling diode? The freewheeling diode is connected across the load, whereas this feedback diode is connected across this switch, this transistor. Okay, so this is our main elements that we are going to need. So let us just connect them. Okay. Okay, these are our basic circuitry. Then see, we are having three phases over here: phase A, phase B, and phase C. Okay, so there we will connect three resistances in star. Okay, so this is our circuit. I have to give gate pulses. Then there are three resistors connected in star, and across each phase I have to measure the phase voltage as well as the line voltage between these two phases. So see, this is VAN, VBN and VCN. These are the phase voltages, and VAB, VBC and VCA, these are the line voltages. Okay, and this is suppose a neutral point, so I have to find out voltages across this point. Okay, and gate pulses, they will be just like 0 to 180 degree. Okay, then the second gate pulse will be, it will start from 60 and end at 60 plus 180, that is 240. Okay, so here we are following the principle that during the phase difference between two transistors switch on is 60. Then this is 120 to 300. Then we have 180 to 360, 240 to 420, and this is 300 to 480. Similarly, we can name this IGBT, IGBT1, IGBT2, IGBT3, IGBT4, 5. What is the principle that we are following here is that no two transistors from the same leg can conduct at a time. That means IGBT 1 and 4 cannot conduct at the same time because it can cause short circuit. Plus, no three transistors from the upper half or lower half will conduct at a time. Okay, so in 180 mode we are considering that three transistors are conducting at a one time. So either two from upper half, one from lower half, or vice versa. Now we will see the detailed explanation of this particular circuit. Okay, these are our gate pulses. Okay, so this is from 0 to 180, then 60 to 60 to 240, likewise. Okay, so now we have to find out how is the phase voltages. So in mode 1 we are thinking that Q1, Q6 and Q5 are operating. You can directly find out from here. See, this is 0 to 60 degree. So from this, okay, just a moment. See, this is from 0 to 60 degree. So during this period, which transistors are conducting? These are Q1, then Q5 and Q6. It is just like the sequence we are following here is our three-phase converter. Okay, we have seen its practical as well, where this was our sequence. Okay, 1 2 3 4 5 6. So likewise here 1 5 and 6, these three transistors we are thinking that these are conducting. So if this is the case, then see 1 5 and 6, so 2 from the upper half and 1 from the lower half. So we can consider that these two resistances, that resistance connected in A phase and resistance connected in C phase, are parallel to each other, and this resistance which is connected to Q6, okay, at the B phase is pass in series to this configuration. Then here we can find out this, these are the upper half transistors. So this is positive, this is negative. Okay, likewise we know if this is DC, these two transistors will directly get positive supply and here it will be negative. Okay, see this plus Vs by 2 minus Vs by 2. Okay, so now here R equivalent will be 3R by 2. I have to find out the current, which is 2 Vs 3R. Vs is source voltage. Now VAN and VCN will be equal, Vs by 3, and VBN will be, this is negative, so minus I into equivalent R. Okay, so this is minus 2 Vs by 3. So I have to plot this here. This is Vs by 3 only for 0 to 60. Okay, VCN is also Vs by 3 and VBN is minus 2 Vs by 3. Okay, so at 60 degree, now what is going to happen? At 60 degree, this Q5 is going to switch off and Q2 is going to switch on. So during 60 to 120, this Q1, Q2 and Q6, these three transistors are conducting. So what we can consider now, that Q1, Q1, Q6 and Q2. See, so these two transistors are from lower half. So these are connected to the negative, current will be divided here. So see, this is negative, this is positive. Here A phase is connected, here B and C. Okay, so B and C means Q6 and Q2. Okay, so RB and RC are connected over here, and this is, okay, this is positive, this is negative. Again the same method we have to follow. We have to follow the, find out R equivalent, then I2 is will be this, then VAN will be I2 into R. Okay, so that is 2 Vs plus upon 3, and VBN and VCN will be negative and divide by 2. Okay, so that is minus Vs by 3. So now we will see this. Okay, so here you can find out during 60 to 120, this VAN is 2 Vs by 3, VBN is minus V by 3, and VCN is also minus V by 3. Okay, so likewise for each mode, okay, 0 to 360, so there will be total whatever different divisions are there for 60 60 each, we have to find out the phase voltages. Okay, now coming back to line voltages, VAB is equal to VAN minus VBN. So we can find out the values here. VAB is equal to VAN minus VBN. Okay, so similarly we can find out these different values of line voltage, VAB minus and VBC and VCA. Okay, VAB is VA minus VAN minus VBN, VBC is VBN minus VCN, and VCA is VCN minus VAN. Okay, so these are the line voltages for 180-degree conduction mode. Okay, so here you can find out the exact table for 0 to 360. Okay, so after this theory part, we will go to our circuit. Now these are the phase voltages voltmeter and these are the line voltages. Okay, so now I will run. Okay, so duplicate name is not allowed. Okay, so we will give it as R1. Okay, 2 and R. Okay, all these three are of same value, so it is of no issue. So first I have to find out VAN. Okay, so see, this is my phase voltage. I will add one more screen, VBN, then VCN. Okay, these are the phase voltages. Then line voltages, VAB. Okay, then VBC and VCA. Okay, so these are the line phase voltage and line voltage waveforms for 180-degree. Okay, so now after this 180-degree, let's coming back to our previous circuit and we will change the conduction angle for 120-degree. Okay, so this, it will conduct from 0 to 120. Okay, then this 60-degree will remain same. Why? Because the conduction of the second transistor starts 60-degree after the first. So 120 plus 120, this is 240. Okay, it is very simple to understand. You can easily, it is very important from your exam point of view, this particular circuit. Okay, so this is 360, then 300, 420. Okay, this is IGBT 6. Okay, I will. Okay, so again we will run the same circuit. This is 3-phase voltage source converter. Okay, so I will first find out VAN. So now here if you see, okay, I will show you, this is VAN, then VBN, and then VCN. So what is the main difference between 180-degree and 120-degree is that in 120-degree at a time, two transistors will be conducting. Okay, so Q1 and Q6 are conducting. Here we can find out this. Okay, so during this 0 to 60, Q1 and Q6 are conducting. So let us see. Q1 is connected in A phase in upper half and Q6 is connected in B phase in lower half. So VCN, that is phase voltage across third phase, will be 0. Okay, why this will be 0? Because there is no current passing through. So see, 6 and 1 is closed, so this is open. So here there will be no current in C phase. So see, VAN is Vs by 2, VBO is minus Vs by 2, because the same voltage is divided in two parts, upper half and lower half, and VCO is 0. Similarly, during 60 to 120, 1 and 2 is closed. 6 is now open circuited, 1 and 2. 1 from upper half, so this is Vs plus 2, and this is VAN, and the lower half voltage, that is VBO, it will be 0, and this VCN will be again minus Vs by 2. Okay, so these are the similar values. So at a time, two thyristors are conducting, and likewise, by taking the difference of these two phase voltages, I can find out easily, I can find out the line voltages as well. Here you can see this is and this, so it is total is Vs. Okay, this is plus Vs by 2, this is minus Vs by 2. So VAB is VAN minus VBN is equal to Vs. Okay, so likewise we can find out the line voltages as well. Similarly, if you want to see VBC, this is minus Vs by 2, okay, minus 0. So this is minus, resultant is minus Vs by 2. Okay, so it is very simple. If you understood the 180 mode, then 120 mode is quite easy. And there is again one more difference, is that to understand easily, that whatever line voltages in 180 mode, the same angle, the same format we are going to get for 120 mode as line voltage. Okay, so this is again one difference. So at the time of study, you can easily grasp these waveforms. Okay, so see, these are initially this was the structure in 180 mode, that of line voltage. So here it is same as phase voltage. Okay, and this 6-step structure, and this is quasi step. So this 6-step structure is of line voltage. Okay, so this is 120 mode and 180 mode for our 3-phase inverters. Thank you.